Hello everyone, welcome once again to our session. Today I'm going to show you the solution of the third example. So we're given here the third example as the integral of the square root of x divided by 1 plus x times dx. Okay, so again this is an irrational fraction. So we have to turn this irrational function into a rational one. Alright, so we'll do the substitution here. So if we let the square root here as our u, okay, so if we let u equal to the square root of x, then from here, if we solve for x, from here we can solve our x by squaring both sides. So if we square both sides here, so we have u squared equal to x. Alright, so from here, if we take the derivative on both sides, so the left side using the power rule, so we have 2 times u times du, and on the right side we have the dx. Okay, so substituting this here in our integral, so we can rewrite this as, instead of square root of x, our square root of x is equal to u, so this is u, then our dx is equal to 2 times u du, so 2 times u, okay, it's too far, so I have to, so our du is 2 times u, then times du, then divided by 1 plus, what is our x? Our x is equal to u squared. Okay, so this is equal to integral of u times u, that is u squared times 2, so that is 2 times u squared du, okay, and divided by, we can interchange the position of 1 and u squared, they're just the same, no? Because that is addition, so u squared plus 1. Okay, we have a constant here, so we can put the constant outside this integral sign, so 2 times the integral of u squared du divided by u squared plus 1. Okay, so if you look at the resulting integral function, this is already a rational one. Alright, so we're able to eliminate the radical or the fractional exponent, so this turned into a rational fraction. Okay, so if you look at the degree at the numerator, so the degree at the numerator here is equal to 2, and the degree at the denominator is also equal to 2. Alright, so this is an improper fraction. Though this is rational, but this is an improper fraction. Alright, so to proceed with this, we have to do polynomial division here. Alright, so doing the polynomial division, you can use also synthetic division, or we call it long division, so it's up to you. Okay, so to do the long division, so we have here u squared divided by u squared plus 1. So we have u squared, so divide this by u squared plus 1. Okay, so this, we have only one term on our this term here, the numerator, we call it I think that is the, we have the dividend, divisor, and the quotient. Okay, so this one divided by u squared is equal to 1. So we have 1 here. So 1 times u squared, that is u squared. Then 1 times positive 1, so that is positive 1. Okay, and then we subtract. Alright, so when we subtract, so the rule here is change the sign of the subtrahend and then proceed to addition. So this will be u squared minus this positive, so this becomes minus, then you add the 2, so this becomes 0. So this one understood to be 0 here. So 0 minus 1, so this is plus, so minus becomes minus, this is plus becomes minus. So when you combine the two, when you add, so we have negative 1. Okay, so therefore our expression now, alright, so let's substitute it here. So we have 2 times the integral of, we have u squared divided by u squared plus 1. This integrand here becomes 1. So 1 is this, the quotient here. Okay, then this is minus, the remainder here is negative 1. So the remainder, negative 1, we have to divide it by the divisor. Okay, so meaning this is negative. So we have negative 1, then divided by the divisor, which is u squared plus 1. Okay, so u squared plus 1. Then everything is multiplied by du. Okay, so this is now our new integrand. Alright, then to proceed, so 2 times we can distribute the 2, the integral, and also the du in each of these terms. So we have 2 times the integral of, we have 1, then times du, so that is the integral of du. Okay, so 1 times du is du, then minus 2. Okay, so 2 times the integral of, we have 1 times du, that is also du, over u squared plus 1. Okay, so take note, class, that we cannot use the partial fractions here because you have u squared plus 1. We cannot factor this. If this is factorable, then the way to proceed with this is to use that technique in partial fraction. But this one, since we cannot factor this, so we have to make use of another method on how to solve this integral. Okay, but we have, if you can still remember from our previous discussion, we have this formula that if you have the integral of du divided by u squared plus e squared, okay, this is equal to 1 over a, right? That is 1 over a times arc tangent, or we have this arc tangent. Sorry, it's not clear, class, so I have to use another pen. Okay, so we have this formula in our trigonometric substitution. We have the integral of du divided by u squared plus a squared. This is equal to 1 over a times the arc tangent, or you can write this as something like this, arc tangent of u over a, then plus c. Okay, so let's check. Let us check this term here. So is it in the form of this one? Yes, I think this part here, our second term, is follows this. So we can use this formula. Alright, because we can write this as, okay, I'll continue it here. I'll continue it here. So this is equal to 2 times the integral of du minus 2 times the integral of du over u squared plus 1 can be written as 1 squared. So from here, our a is equal to 1. Alright, so from here, our a is equal to 1. Then using this formula, okay, so using this formula, so we can now write our answer as 2 times integral of du is simply equal to u minus 2 times, so using this formula, 1 over a, so 1 over a, our a is equal to 1, times the arc tangent. Okay, so arc tangent of u over a. What is our u? So our u is simply u. So u over a, our a is equal to 1. Okay, then plus c. Or this is equal to 2 times u minus 2 times arc tangent u plus c. Okay, I'll continue it here. Then substituting the value of our u, where our u, we have our u here. Our u is equal to square root of x. So substituting it to our equation here. So we have 2 times our u is square root of x, then minus 2 times arc tangent of square root of x, then plus c. Okay, so this is our final answer. Alright, so I hope you understood what I have presented to you, class. Thank you. And any question, you may just message me in our GC. Bye.